factoring the sum and difference of perfect cubes. I think the hardest thing about this method compared to the sum and difference of squares is just identifying. Is it a sum or difference of squares, or is it a sum or difference of cubes? And the reason why I say that is because in this particular method, like yesterday's particular method, there's two terms, and the sum and difference of squares and the sum and difference of cubes. The difference here, bad word choice on my part, is that we have to have two cubes in this problem, whereas we had to have two perfect squares in our earlier notes. But let's talk about what a cube is, like we did with our squares. And a cube is simply something times itself 3 times. 1 cubed is 1 times 1 times 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 4 times 4 times 4, which is 64. 5 cubed is 5 times 5 times 5, which is 125. And 6 cubed, it's 6 times 6 times 6, which is 216. And 7 cubed, I have to look, I have to admit, 7 times 7 times 7 is 343. 8, I kind of know. 8 cubed is 8 times 8 times 8. I remember it from the quick recalls. 9 times 9 times 9, I have to look. 729. And 10 times 10 times 10 is 1,000. So we look for these numbers when we're dealing with the cube. But even more specifically, when we're looking to factor a cube, look for a variable with the exponent of 3 or a multiple of 3. 3, 6, 9, 12, 15, 18, 21. The variables on the exponents can give it away. Cube is going to be, again, to the 3rd power, to the 6th power, to the 9th power, whereas a squared is going to be to the 2nd power, to the 4th power, to the 6th power, right? Yes, we could do that, but it's going to be multiples of 2. So when we look at this here, it depends on your teacher. Some teachers like to teach it in terms of memorizing. I personally am not a big fan of memorizing. And believe me, I think there is a time and a place to memorize. I just hope that I can teach this to you without it. But there's a pattern to factor in a cube. First of all, it turns into a binomial, which is a 2-term expression, times a trinomial, which is a 3-term expression. And when we factor this, what we do is we're going to take the cube root of a cubed, which is a. A times a times a. Cubed root of b cubed. B times b times b. And then there's this method that I found a few years back called SOAP. Same sign. So this is a plus, so that's going to be the same sign. Opposite sign. So here's a plus, so our opposite sign is going to go right here. And AP, always positive. So S, same sign. Same sign. Opposite sign. Oh, opposite. Always positive. AP. And then, here's the last part. A cubed divided by A is A squared. We had 3 A's, we took out 1. b cubed divided by b. Notice where I'm going to put it. We had 3 b's, we took out 1, and put it here. And finally, the last part. Remember, we already have the signs in there, so we're going to take a, and we're going to multiply it by b. Whatever's there, a times b. The pattern does not dramatically change when we have a cubed minus b cubed. A cubed. Cube root of a cubed is a. Cube root of b cubed is b. A times a times a. B times b times b. Same sign. Opposite sign. Always positive. And then we can fill in the rest. A cubed divided by a is a squared. B cubed divided by b is b squared. And the last part, a times b is ab. We already have the signs in there. So now let's use this method on our 4 examples. So when we start here, x cubed, the fact that that exponent is a 3 indicates to us that we should be looking for a cube. We're going to turn this into a binomial and a trinomial. And what's the cube root of x cubed? Well, x times x times x is just x. Cube root of 125. You can look back at your chart up here on your paper. 125 is 5 times 5 times 5. So the cube root of that is the cube root of 125 is 5. Same sign. But let me show you how to do the cube root on your calculator as well, if you don't know. It is the math button. Math. Number 4. And then 125. This is 5. Math. Function number 4 is 125. And we get 5. And what I did so far, same sign. So that means we're going to have opposite signs and always positive. To finish, x cubed divided by x is x squared. We had 3 x's, we took out 1, we still have 2. 125 divided by 5 is 25. You can type that in your calculator. Notice where we put that. This is important because of the sign. And lastly, x times 5 goes here. Let's try another one. X cubed minus 216. It's x cubed. Strong indicator that we're going to be turning it into a binomial and a trinomial. The cube root of x cubed is x. X times x times x. If you look back at your above on your paper here, 216. Well, 216 is 6 times 6 times 6. So the cube root of 216 is 6. Same sign. Opposite signs. Always positive. And then x cubed. Jordan?
Wouldn't the second one be a negative?
This one's always positive.
Oh,
Every single time. Always positive. Good to get that clarified. So x cubed divided by x is x squared. 216 divided by 6. Well, let's type it in. 216 divided by 6 is 36. Make sure to put it in the right spot. Then the last part is x times 6, which is 6x. Once you get the hang of the pattern, I hope that these will be fairly easy for you. Again, recognizing that easy is never a term to be used in math, at least not very often, because some people it's never going to be easy for. But what we do need to watch out for is, do we have a GCF? And as we look at this problem here, do we have a GCF between 64 and 27? No. And in fact, if we go back and look at the top of our paper here, 64 is a perfect cube and 27 is a perfect cube. So we're good there. And we can break this down into a binomial and a trinomial. When we look above on our paper, or we type in the cube root of 64, we find out that we get 4. The cube root of x cubed is x. When you look at the top of the paper, 27 is 3 times 3 times 3. So it's going to be 3y. Then we're going to have same sign. Well, same sign, opposite sign, always positive. So, S for same, O for opposite, AP, always positive. 64 divided by 4 is 16. X cubed divided by x. We had 3, we took out 1, we got 2 left. 27 divided by 3 is 9. Y cubed divided by y. We had 3, we took out 1. Got 2 left. And finally, remember, we already have the signs in there. 4x times 3y. 4x times 3y is 12 xy. 4 times 3 is 12. As we finish, when we look at these factoring problems, no matter what kind, whether it's split the middle, whether it's grouping, we should always be looking for greatest common factors. Do we have a greatest common factor in this problem?
5.
And it is a 5. So we're going to take out that 5, and we're going to be left with x cubed times 8. 5x cubed divided by 5 is x cubed. 40 divided by 5 is 8. Well, x cubed and 8 are perfect cubes, so we can keep factoring. And when we do, x cubed is x times x times x. 8 is 2 times 2 times 2. Same sign. Opposite signs. Always positive. Well, x cubed divided by x. We had 3 x's, we took out 1, we got 2 left. 8 divided by 2 is 4. Make sure that you put it in the right spot. And the last part is x times 2. It's 2x.